Bismillah ar-Rahman ar-Rahim. These are some exercises about section 5.4 indefinite integral. So in the first set of exercises, find the general definition find the general indefinite integral. Well, you have to remember the formulas that are in the lecture. So please see the video about 5.4 first before and memorize the formulas before solving these exercises. Uh, to find this integral, I write it x to the power 5 over 4 dx. Okay, there is a formula that enables you to change the power. If you have the nth root of b to the power m, you can write it b to the power m over n. So this is the one I used here. And now I can use the formula for integral x to the power n. We add 1 to the power, so 5 over 4 plus 1, we will have 9 over 4 over 9 over 4 plus c. And now this 9 over 4, I can bring it up and write it as 4 over 9 x to the power 9 over 4 plus c, and this would be the answer. Here, I need to expand first because I don't have a formula for the product. So u times 2u is 2u square. 4 times 2u is 8u plus 1u. So I will have 9u. 1 times 4 is 4 du. So the answer would be 2 times u 3 over 3. We add 1 to the power plus 9. 9 is a constant, we take it out, and then we add 1 to the power, so 2, and we divide by that number, plus 4, and the integral of 1 is u plus c. So that's the answer. Here, I have to distribute the numerator over the denominator first. So I write it 1 over x plus square root of x over x plus x over x, which is 1 dx. And then I write all of them in the power as a power of x. So 1 over x would be x to the power negative 1. So I leave it 1 over x because there is a formula especially for 1 over x. Here, this is x to the power half minus 1. So I will have x to the power half minus 1, which is negative half, and plus 1 dx. And now I can use the formulas. Integral of 1 over x is ln absolute value of x. Integral of x to the power negative half, I add 1 to the power. So negative half plus 1 is half, and I divide by half, plus the integral of 1 is x plus c. Finally, I can write it ln absolute value of x over half. I can bring it up as 2. You can write this as square root of x, or just leave it x to the power half plus x plus c. Here, the integral of e to the power x is just e to the power x, and the integral of 1 over x is ln absolute value of x plus c. Here, the integral of 2 is 2 times x, and the integral of 3 to the power x is 3 to the power x over ln 3 plus c. Here I have to expand. So I write it. If you expand, you have 1 square, which is 1, plus 2 times r times 1, which is 2r, plus r square over r. And then I distribute the numerator over the denominator. 1 over r plus 2r over r will be cancelled with r, and I'll have 2, plus r square over r is r. 2 minus 1 is 1. dr. Now I can find the answer. Integral of 1 over r is ln absolute value of r. Integral of 2 is 2r. Integral of r is r square over 2 plus c. Here I cannot distribute the integral. It's not integral on the product. If there is a product, I cannot distribute. So what should I do? There is no formula like this. But if you multiply, if you expand, secant times secant will give you secant square t. And then secant t times tan t. Do we have formulas for integral of secant square? Yes. Integral of secant square is tan t, because the derivative of tan is secant square. And integral of secant tan is secant t, because the derivative of secant is secant tan plus c. So that's the answer. Here I have a formula. Sine 2x equals 2 sine x cosine x. This is a very important and known formula about sine 2x. It's 2 sine x cosine x over sine x dx. So sine x cancels with sine x, and then 2 comes out, and the integral of cosine is sine, because the derivative of sine is cosine. So that's the answer. In the other uh, part, uh, we have questions about evaluating the definite integral. The only difference, we will evaluate the indefinite integral first, and then we replace by 2 minus 0, b minus a. So to find the integral of this, I need to expand. Okay, I need to expand. So 2x times 4x squared, 8x cubed. 2x times 1, 2x. Let me do negative 3 times 4x squared first. So I'll have negative 12x squared. To write them in order, just preferring the order. 2x plus 1 is 2x, and negative 3 times 1 is negative 3. So when we expand, we get these 4 terms, dx. And now we can find the integral. So 8 is 8, and the integral of x cubed is x to the power 4 over 4, and this from 0 to 2, minus 12. X cubed, I write it x to the power 4. Is this x cubed? No, this is x squared. Okay, this is x squared. Because negative 3 times 4x squared is negative 12x squared. So the integral would be 12x cubed. I add 1 to the 2 over 3 plus integral of x, of course, from 0 to 2. Integral of x is x squared over 2 minus 3x. All of them are from 0 to 2. So I will have 8 over 4 is 4. So the numbers, you just take them out. And now x to the power 4, you replace x by 2. So 2 to the power 4, which is 16, minus 0 to the power 4, which is 0. Minus 12 over 3 is 4. and then 2 to the power 3, which is 8, minus 0. 2 over 2 is 1. So 2 to the power 2 is 4, minus 0, minus 3 times. You just replace x by 2 minus 0. And you can evaluate this or use the calculator to help you. So 4 times 16, that's 64, minus 4 times 8, that's minus 32, plus 4, minus 6, and the answer is 30. To find this integral, I need to write it first as 1 over x squared. I will write it x to the power negative 2. I take x squared up, so the power would be negative. Why? To use the formula x to the power n minus. The 4 is a number, and x to the power 3, I write it x to the power negative 3 because you take it up dx. So the answer would be the integral of x to the power negative 2 is x to the power negative 1 over negative 1 because we add 1 to the power minus 4. The integral of x to the power negative 3 is x to the power negative 2 over negative 2. And I add 1 to the power. All of this are from 1 to 2. So I will write it as this negative 1, I can take it up, okay? And x minus 1, I will write it 1 over x, and I will take it from 1 to 2. Then minus 4 over minus 2, this is plus 2. And x to the power negative 2, I will write it 1 over x squared and take it from 1 to 2. So I have minus, I replace x by 2, so 1 over 2, minus, I replace x by 1, so I have 1, plus 2 times. I replace x by 2, so I have 1 over 4, minus, I replace x by 1, so I have 1, and I find the answer. So this is half minus 1, negative half times negative is just half, and this is 1 over 4 minus 1, negative 3 over 4 times 2 is negative 3 over 2, and 1 minus 3 is negative 2 over 2, so the answer is negative 1. To find this integral, I need to distribute first the numerator over the denominator. So 3x squared over x will give me 3x plus 4x over x, I'll have 4, and plus 1 over x dx. So the integral of 3x is 3x squared over 2 from 1 to 3, plus integral of 4 is 4x from 1 to 3, plus integral of 1 over x is ln absolute value of x from 1 to 3. So it would be 3 over 2 times 3 square, which is 9, minus 1 square, which is 1, plus 4 times x, I replace it by 3 minus 1, and plus ln, replace x by 3, so ln 3 minus ln 1. Well, ln 1 is 0, okay, you know that. So this would be 3 over 2 times 8, this is 12, plus 3 minus 1 is 2 times 4, this is 8, plus ln 3. So the exact answer would be 20 plus ln 3. That's the exact answer of this definite integral. I need to expand, okay, square the binomial and multiply by the t. So first, when you expand this, square of 1 is 1, minus 2 times 1 times t, 2t, plus t square. And now I will multiply by t. So t times 1 is t minus 2t square plus t to the power 3. You have to do it like this. You cannot distribute the integral if there is a product. So the integral of t is t square over 2 from negative 1 to 1 minus t cube over 3 from negative 1 to 1 plus t to the power 4 over 4 from negative 1 to 1. Notice that I can take the 2 out, so it's half. And then I replace t by 1. 1 square is 1 minus negative 1 square is also 1. So this would be 0 minus 2 over 3. 2 over 3. And now I replace t by 1. 1 cube is 1 minus. Minus 1 to the power 3 is also minus 1 plus 1 over 4 times t to the power 4. So 1 to the power 4 is 1 minus negative 1 to the power 4 is also 1. So this is also 0. So the answer would be this is 1 plus 1, 2. So negative 4 over 3. Negative 2 over 3 times 2. That's the answer. Here I have to distribute. So this would be 4 over square root of u. I will write it 4 times u to the power negative half, because this is u to the power half. If you take it up, it would be negative half plus 6. Now u over square root of u, 1 minus half is half. So I will have u to the power half. Now I can find the integral. So 4 times u to the power negative half. I add 1. So 1 minus half is half over half from 1 to 4 plus 6 times u to the power half plus 1 is 1.5 over 1.5 or 3 over 2 from 1 to 4. So 4 divided by half would be 4 multiplied by 2, so it would be 8. And u to the power half from 4 to 1. So 4 to the power half, which is 2, minus 1 to the power half, which is 1, plus 6 over 3 over 2 would be 6 times 2 over 3. So 6 times 2 over 3 would be 4 times u to the power 1.5. So 4 to the power 1.5 minus 1 to the power 1.5, which is 1. You can evaluate 4 to the power 1.5 by yourself, or you can use the calculator to find that it is 8. So 2 minus 1 is 1 times 8, so I have 8. And here 8 minus 1 is 7. 4 times 7 is 28. So the answer is 36. I have a formula for 1 plus p square. 4 comes out, and I'll have integral of 1 over 1 plus p square dp, and this is tan inverse p. The integral of this is tan inverse p from 0 to 1. So it's 4 times tan inverse 1 minus tan inverse 0, which is 0. Okay, tan inverse 0 is 0. So the answer is 4 tan inverse 1. And if you want, you can find tan inverse 1 using the calculator, and the answer would be pi over 4. Okay, so 4 times pi over 4, so the answer is pi. Here I need to expand and to change these two powers. So I will write it x times this 1 cube root of x. I can write it x to the power 1 over 3 and this is fourth root, I can write it x to the power 1 over 4 dx. And then I multiply, expand. So x times x1 over 3 would be x to the power 1 plus 1 over 3, which is 4 over 3, and x times x to the power 1 over 4, 1 plus 1 over 4, which is 5 over 4. And now I can use the formula x to the power n. So the integral of x to the power 4 over 3 would be x to the power 4 over 3 plus 1. So 7 over 3 over 7 over 3, or I just write it 3 over 7 here, from 0 to 1, plus x to the power 5 over 4 would be x to the power. I add 1. So 4 over 4 plus 5 over 4 would be 9 over 4. Over 9 over 4, or multiplied by 4 over 9, and also from 0 to 1. So I have 3 over 7. If you replace x by 1, 1 to 7 to the power 7 over 3 is just 1 minus 0. And here 4 over 9, also 1 to the power 9 over 4 is 1, and 0 to the power 9 over 4 is 0. So the answer is 3 over 7 plus 4 over 9. And you can add these two numbers using the formula for adding fractions, or if you use the calculator, the answer is 55 over 63. I need to write it as follows. Distribute. This is y to the power half minus 2, half minus 2, negative 1.5, minus 1 minus 2 is negative 1, or 1 over y dy. So y to the power negative 1 over 5. If you add 1, you will have y to the power negative zero point 0.5, or negative half, over negative half, from 1 to 4, minus integral of 1 over y is ln absolute value of y from 1 to 4. So I will have this one comes up as negative 2, and I will write this 1 over square root of y from 1 to 4. And here I have ln 4 minus ln 1, which is 0. So this would be equal to negative 2 times 1 over square root of 4, which is 1 over 2, minus 1 over square root of 1, which is 1, minus ln 4. Now half minus 1 is negative half. Negative times negative is positive. 2 times half is 1. So the answer is 1 minus ln 4. Here I will write it as half times integral from 1 to 2 x dx. So it's x over 2. I can take 1 over 2 out like this, minus. Here the 2 is in the numerator. I will take it out and leave 1 over x inside the integral. So now also this is from 1 to 2. This is half integral of x is x to the power 2 over 2 from 1 to 2, minus 2 times integral of 1 over x would be ln absolute value of x from 1 to 2. So it would be equal to 1 over 4, 2 times 2, and I replace x by 2 squared, so 4 minus 1 squared, which is 1, minus 2 times ln 2 minus ln 1, and ln 1 is 0. So I will have 4 minus 1 is 3, and this is negative 2 ln 2. So that's the exact answer. Here, the integral of 5x is 5x squared over 2 from 0 to 1, and the integral of 5x is 5x over len 5 from 0 to 1. So I have 5 over 2 and I replace x by 1. So 1 square is 1 minus 0 square is 0 minus. Now len 5 is just a number. So I will take it out and I replace x by 1. So I have 5 to the power 1 which is 5 minus 5 to the power 0 which is 1. So I will have 5 over 2 times 1, okay, minus 5 over len 5. So this would be the exact answer. Here, I need to do something because I have a fraction. So I will write it as 1 over cosine square plus cosine square over cosine square, which is 1. Good. What is 1 over cosine square? It is secant square plus 1. I don't have an integral of 1 over cosine square, but I have an integral of secant square. Integral of secant square is tan, because the derivative of tan is secant square. So tan theta from 0 to pi over 4 plus the integral of 1 is theta from 0 to pi over 4. So now it would be tan pi over 4 minus tan 0, okay, plus pi over 4 minus 0. Well, tan pi over 4 is 1, okay. You can check that using the calculator. It is 1. And tan 0 is just 0. So this is 0. So the answer is 1 plus pi over 4. Here, if you look carefully to the question, you will notice that if you take sine theta as a common factor from the numerator, you will have 1 plus tan square theta over secant square theta. And in fact, we have some formulas in geometry. We know sine square theta plus cosine square theta is 1. Now, if you divide each term here by cosine square, then sine square over cosine square is tan square, and cosine square over cosine square is 1, and 1 over cosine square is secant square theta. So this is another formula that relates tan and secant. So 1 plus tan square is actually secant square. So I can write this as from 0 to pi over 3 sine theta times secant square theta over secant square theta. I cancel these two. And the integral of sine is negative cosine, because the derivative of cosine is negative sine from 0 to pi over 3. So the answer would be negative. Replace theta by pi over 3 and then replace theta by 0. So what is cosine pi over 3? I think it is just half. So this is half. And cosine 0 is just 1. You can always use the calculator to check. So it's 1. So half minus 1 is negative half times negative. So the answer is just half. Now here I need to rewrite this. So I will write it first as square root of 3 over square root of x, distributing the square root. Then square root of 3 is just a number, so I can take it out. And I'll have 1 over square root of x. I will write it x to the power negative half. It is already x to the power half here. If you take it up, it would be x to the power negative half. Why? Because now I can use the formula of integral x to the power n. So I will have square root of 3 times. What is the integral of x to the power negative half? I add 1. So it is 1 over half, x to the power half over half from 2 or 3, sorry, to 4. All right. Now, square root of 3 over half is 2 times the square root of 3. And I replace x by 4, so I will have 4 to the power half, which is 2, minus the square root of 3. So the answer would be 2 times 2, 4 square root of 3, and square root of 3 times square root of 3 is just 3 times 2, 6. So that's the answer. I have a formula for 1 over 1 minus r squared. This is immediately sine inverse. So it's sine inverse r from 0 to square root of 3 over 2. So the answer would be sine inverse of square root of 3 over 2 minus sine inverse of 0. Well, sine inverse of 0 is just 0. So this would be the answer, the exact answer. Now to find here this integral, I can write it as t square minus 1. I leave it as it is. But I can factor t to the power 4 minus 1 using square difference of two squares formula. So it would be t square minus 1 times t square plus 1. And now this cancels with this. And I have 1 over t square plus 1 dt. But I have a formula. The integral of 1 over t square plus 1 is tan inverse t from 0 to 1 over square root of 3. So it would be tan inverse 1 over square root of 3 minus tan inverse 0, which is 0. So this is the exact answer. The last question is about absolute value. We know that absolute value of 2x minus 1 equals either 2x minus 1. If 2x minus 1 is greater than or equal to 0, this means 2x is greater than or equal to 1. This means if x is greater than or equal to half. And we will have negative 2x plus 1, negative this, if x is less than half. So here the integral, the definite integral is from 0 to 2. So from 0 to half, less than half, the absolute value would be equal to negative 2x plus 1 plus. Now from half to 2. From half to 2, it's greater than half, so the absolute value would be equal to 2x minus 1. And now the integral of this is negative 2x squared over 2, and the integral of x is, if 1 is x, all of them are from 0 to half. And here 2x squared over 2 minus x from half to 2. I will solve it this time as follows. 2 divided by 2, it would be negative x squared plus x from 0 to half plus 2 over 2 is x is 1, so x squared minus x from half to 2. I will replace first x by half. So I will have negative half square, which is 1 over 4, plus half minus. Now replace x by 0, 0 square plus 0. So this is just 0 plus. Here I replace x by 2. 2 square is 4 minus 2 minus. Now I replace by half. Half square is 1 over 4 minus half. You evaluate this by the calculator. You will find that this is negative 1 over 4 plus 2 over 4. So this is 1 over 4. 4 minus 2 is 2. 1 over 4 minus 2 over 4 is negative 1 over 4 times minus. So it would be positive 1 over 4. So the answer is 2.5. That's the end of these exercises. I hope you have enough exercises to study. Thank you very much.